Hello everyone, welcome back to the Abhyaas IIT Corporation IIT preparation team. So my name is Dr. Karthikeya. So today, especially in this video, we are going to discuss work power energy 2024 JEE mains questions, both shifts, that is April and January. So for solving this kind of problems, so especially this work power energy problems are very easy. So for solving this kind of problems, we need the basics of what is work, what is power, what is energy, what is conservation of energy. Especially we are dealing with mechanical energy here, conservation of mechanical energy. So conversion of potential to kinetic, or sometimes both will be there. Okay, at some locations. So we need to have this kind of basics, and also we need the basics of differentiation and integration. So basically these are the concepts you need to be thorough. Everybody knows that work is product of force into displacement, whereas power is product of force into velocity. Here we are also taking the dot product. So because work is a scalar quantity, it will come like that. Because work is equal to force into displacement. Force is a vector and displacement is another vector. If you multiply both vectors with the help of dot product of two vectors, will give a scalar. Similarly, power is also scalar. It is a product of force into velocity. Both are vectors. So dot product of force vector and velocity vector gives power. Similarly, energy is also having same units as that of work. Energy is the capacity to do work, where work is a manifestation. You can clearly understand like that. So whereas energy, mainly in this chapter we are dealing with kinetic energy and mechanical energy. Yeah, mechanical energy is a combination of kinetic and potential. So potential energy, everybody knows potential energy is a energy possessed by a body due to its position, means height, elevation. So whereas kinetic energy is the energy possessed by the body due to its motion. So due to its velocity, practically. So a body moves with a certain velocity, have kinetic energy. Whereas when a body is at a height or elevation, height h, so then it is having potential energy. If both are there, then we have both type of energy. But according to law of conservation of energy, energy can be neither created nor destroyed, but converts from one form to another form. So these basics should be known. And also for solving problems, we need what is meant by momentum. Momentum you have studied in, especially in this chapter of Newton's law of motion. Momentum is a product of mass into velocity. Everybody knows that is a vector product, vector quantity. It is a product of mass, it's scalar, whereas v bar vector is, velocity is vector. So finally we'll get vector. Okay, you also need relation between kinetic energy and momentum. So that relationship also you should know. These are some of the things you need to know before solving the problems. So for solving any problem, we need to be thorough with the concept. That's why I just have done a recap of that. So yeah, welcome to the again back to these questions. We'll solve the questions in a step-by-step manner with concept wise. I made the slides, so you just check it. Yeah, first of all, first concept is work done by constant force, variable force and kinetic energy. So here if you observe, yeah, two bodies of mass 4 grams and 25 grams are moving with equal kinetic energy, the ratio of magnitude of the linear momentum. So we know kinetic energy generally K is equal to half mv square. Okay, here if you multiply mass in the top and bottom, so what you will get? M square V square, that is called P. P square by 2m. K is equal to P square by 2m. This is the relationship between kinetic energy and linear momentum, that is P. Here what is asking? Equal kinetic energy. So two masses are there. One is M1 4 grams, M2 is 25 grams. Okay, M2 is 25 grams. So kinetic energy is equal. That means Ke1 equal to Ke2. So P square by P1 square by 2m. 1 is equal to P2 square by 2m. Okay, P1 by P2, if you calculate P1 by P2 is equal to M1 by M2 for that power 1 by 2, because it's square this side, that side it will be like that. So P1 by P2 we want, that is linear momentum. So M1 is 4 by 25. So for that 1 by 2 is there, that is P1 by P2. So what you will get? 2 by 5. This is the answer. So it's a simple, so just you can calculate the things. Okay, this is the first one. So very simple, right? Yeah. Now going to the second one. A block of mass 100 kgs slides over a distance of S equal to 10 meters over a horizontal surface. So there is a horizontal surface, body of mass 100 kg slides for 10 meters. Okay, coefficient of friction mu is equal to 0.4. So frictional force F equal to, what is the formula? Mu n is equal to mu mg. Okay, this is the thing. N is in the top direction because it's contact surface. This is normal reaction. There is a contact surface here. Mg will be down and weight is in the down. N is in the up. So work done equal to mu mg s, because force into displacement. What is the force? Frictional force. He asked work done against friction. So the body is moving like this, friction will be in the back. So that is in negative direction. So here if you see, mu value is given, that is 0.4. Mass is how much? 100 kgs. Into g value is 10 you can consider, and distance is also 10. So what is the answer? 0.4 into 10 power of 4, that is 4 into 10 cube, that is 4000 joules. So this is the answer. Okay, work units are joules, that's why I written 4000 joules. This is also a very simple bit. This is the answer. Yeah. Now see this, another kind of problem. Here a body of mass m 1 kg is pushed along the incline to the horizontal with a force parallel to the inclined surface. And what is the angle of wedge? This is wedge. Okay, that is 60 degrees. Mu s is given as 0.1. Here also he is asking work done against the friction. So friction will be in the downward direction if the body is moving to the top like this. So what is the work done? Work done equal to force into displacement. What is the force? Work done against frictional force. That force you have to consider. Distance traveled is how much? 10 meters. So again mu, but here mg is like this. Mg is like this. If you resolve into component, this is mg cos theta. Okay. So that is top one is n. So we know friction is equal to mu n. That, but n is equal to what? Mg cos theta. Actually it's like this. N is like this. So that is opposite to this one. N will be opposite to mg cos theta. Contact surface is like this. Mg cos theta. Okay. Mg sin theta. Okay. So it's exactly the figure. Opposite to n, this is mg cos theta. Okay, like this. This is a contact surface. N will be like this. Mg cos theta, exactly like this. Okay, mg is like this. Okay, here work done equal to mu n, frictional force into displacement. Mu mg cos theta into displacement. So mu is how much? Mu is how much? 0.1. 0.1 into mass is 1 kg. G is 10. Cos 60. Cos 60. Into displacement is how much? Displacement 10 meters. Okay. Displacement is like that. Mu mg cos theta. Mu is 0.1, m is 1 kg, g value if you take 10, cos 60, okay, into displacement is 10 meters. So what you will get? Cos 60 value is how much? Okay, is 1 by 2. Okay, 10 into 0.1 is 1 only. Okay, 10 into cos 60 is 1 by 2, that is 5 joules. This is the answer, 5 joules. Okay, option C, option B. Okay, this is also simple bits, so you can easily solve this kind of problems. Now again another one. So here a artillery piece of mass m1 fires from a shell of mass m2 horizontally. So what happened here? So whatever initial momentum is there, so before firing there is no momentum, but after firing what happened? So momentum of the artillery is equal to the momentum of the shell. So from the formula Ke is equal to p square by 2m. So what is asking? Ke of artillery divided by Ke of shell. So Ke is inversely, if momentum is same, here artillery momentum and shell momentum are same because it is coming from that only. So initially there is no momentum, but direction is opposite. This side shell is, artillery is going. Okay, so Ke is inversely proportional to m. Okay, Ke artillery, that is Ke1 if you consider, Ke2 is shell. So that is proportional to 1 by m means Ke1 by Ke2 equal to m2 by m1. So that is the answer. M2 is shell, m1 is artillery. Okay, this is the answer. So Ke is inversely proportional to mass. That's why we are getting Ke1 by Ke2 equal to m2 by m1. Simple. So it's not a big deal. Only thing is you have to understand that momentum is constant. So that is m1 v1 equal to m2 v2. So it will be it is same for both. Another thing, here bullet is fired with a speed on a plywood. So if you see, bullet is fired towards a plywood like this and emerges with 40 meter per second. Okay, initially that is 100 meter per second. Okay, Ke initial is this one, Ke final here if you calculate, what is the mass of m v1 square, here of m v2 square. What is asking? Percentage loss of kinetic energy. That means change in kinetic energy by original kinetic energy. So percentage loss is equal to, in Ke is equal to delta Ke by Ke initial. So this is half m v2 square minus half m v1 square divided by half m v1 square. So m is cancelled and all the things. So v2 square, that is 40 square minus 100 square into 100. This is there by 100. So into 100. Okay, this is the thing. So 1600, you can easily calculate 40 by 100. Okay, square minus 1 into 100. You just calculate this. That is 2 by 5 means. Okay, Ke final. So this is modulus. So negative will be positive only. So if you calculate it is around 84%. You just calculate this. Okay. Okay. Yeah. Next one. Here kinetic energy. We have to calculate. Here 4 masses are there. M by 2, M, 2M, 4M. Having same momentum respectively, particle with maximum kinetic energy. So here what we have to calculate? Here he is only telling same momentum. Again same formula, Ke is equal to p square by 2m, but momentum is same for all the things. Then again Ke is inversely proportional to mass. Ke is inversely proportional to mass. If it is there, which is having less mass, kinetic energy is more. So of the 4 which is having less mass, m by 2, m, 2m, 4m, 4 are there. M by 2 is lesser, so Ke for m by 2 is maximum. Okay, so which is one? A is answer. Okay, simple thing, no need to worry about things. So one formula only making us to solve 3-4 problems in this JEE mains. Again same type of the things. Again kinetic energy only. Here, when the kinetic energy becomes 36 times original value, okay, Ke is equal to P square by 2m, again same formula, but what is asking? Kinetic energy is equal to 36 times original value. So P, why I am taking P? Because he is asking increase in the momentum of the body. If you consider Ke1 is equal to, first you can consider Ke only, first one. So simply I will tell you this thing. Ke is equal to P square by 2m. P is equal to 2m Ke root or things. Okay. So P final is equal to root 2m 36 Ke. Okay. Initial is 2m Ke. After that it is 36 Ke. That means if you consider Pi is equal to 2m Ke. Pi equal to 2m Ke. Afterwards 6 times 2m Ke. So that means P final is 6 times P initial. What is asking? Percentage increase. That is delta P by Pi into 100. So P final minus P initial by P initial into 100. So that is 6 minus 1 by 1 into 100. That is how much? 500. Increase in the percentage he asked. That's why it's 500. Okay. How many times it increased means? 6 times means 600. But initially if it is 100, it will be 600. But increase means 600 minus 100, that is 500. Directly you can get. Okay. Now going to the another one. Here also same type of problem. 3 bodies ABC have equal kinetic energy and their masses are there. Here same formula. So what is the formula? So K equal to P square by 2m. Most of the problems are only similar type. Ke is equal to P square by 2m. But what he is telling? Equal kinetic energy. Kinetic energy is same for all the things. Then P square is proportional to 2m or P square is proportional to m. So P is equal to root m into constant, that is a K root m. Okay, K root m. So what happens now? If you take P1 by is to P2 is to P3 is a ratio of root m1 is to root m2 is to root m3. Here first one is 400 grams, directly I am writing. Second one is 1200 K, 1.2 means 1200 grams. Third one 1.6 means 1600. So if we take root 400 common for all the things. So root 400, this one 3, root 3 into root 400. This is 2 into 400. That means what is the answer? 1 is to root 3 is to 2. Okay, that is the answer. Here first option. So these are only based on 1 or 2 formulas only. We completed this one, simple bits. So now going to the work done by. Work done is asking force is given, displacement limits are given. So here we need force is variable force because as x is changing, force is changing. So what we want? Work equal to force into displacement. General formula only. But here the force is variable force. That's why work done is equal to integral of f dx. So here force is varying with displacement. So that is from 2 to 4. Okay. So if you consider here 2 to 4. So 3x square plus 2x minus 5. Okay. 3x square plus 2x minus 5 dx. Here what you will get? So if you apply the integration for this, okay, what happened? 3 into x cube by 3 plus 2 into x square by 2 minus 5x. So from limits 2 to 4. 3 get cancelled, 2 get cancelled. X cube minus plus x square minus 5x. You just apply the limits from 2 to 4. What happened? 4 cube plus 4 square minus 5 into 4 minus 2 cube plus 2 square minus 5 into 2. 4 cube is 64 plus 16, how much? Okay, I'll write 64 plus 16 minus 20. Okay, here 8 plus 4 minus 10. Here this one 16 minus here 8 plus 4 12. 60 minus 2, that is 58 joules. Answer is 58. Okay, so this is simple only you need integration concept, so you can easily calculate. Okay, now going to the another one. Now we come to the important thing, that is work energy theorem. So from the work energy theorem we have to understand work done is equal to change in kinetic energy. So here what happened in this kind of problems, what happened, particle is placed initially at A, that is not moving, so that means here there is no energy. Work energy theorem means work done equal to change in kinetic energy. Another thing, concept is mechanical energy conversion. Here what happened in this kind of problem, so conversion of mechanical energy is, takes place. So here at the point A we have height. Height means which type of energy will be there, potential energy, and the body is not moving. Here is placed at the point of frictionless track as shown in figure. It is gently pushed towards right. Slowly it pushed towards right. What happened? It will come down. Speed of the particle when it reaches the point B. Here G value is given. Here at the point A there is no velocity. That means whatever mechanical energy is there, that is because of potential energy only. Okay, here conversion of energy. So I'll write here, first thing we are taking UA plus KA, that is the total mechanical energy is equal to potential plus kinetic at point A to point B. Why I am taking? Because this is law of conservation of energy. So energy can be neither created nor destroyed, but converts from one form of energy to another form. Here there is no kinetic energy because this body is not moving, whereas at A there is no change in the no velocity. That means it's only potential energy, that is mgh. Mg into height is how much? 1 meter, plus kinetic energy is 0. Here UB is mg into 1 by 2, I am writing directly, plus of mvb square. Vb only we want. Okay, mg minus mg by 2 is equal to of mvb square. Okay, this is mg by 2 is equal to mvb square by 2. Okay, m by 2 cancelled on both sides. Vb is equal to G value root 10. That is the answer, meter per second. This is the answer. Okay, Vb equal to root 10 meter per second. Simple bit. Another thing also, here in this particular type of problem, rubber ball is falling from a height h, hitting the ground and going to the top. That means we know when an object is freely falling from the top, initial velocity is nothing. Final velocity is equal to, you can easily know, right, from the kinematics chapter, 0 square minus v square is equal to minus 2gh. So v is equal to root 2gh. Before it hitting, the value is root 2gh. After hitting, what happened? V after hitting, same. It is a 2g h by 2 because it is going up to h by 2 only. Okay, so here what is asking? Percentage loss of total energy of this initial system as well as velocity of ball is striking the ground. So velocity of ball striking the ground, we got a root 2gh. But what you want? So loss of total energy, that means delta ke is by ke. Okay, here of m v after v, yeah, after I am taking this a, before I am taking vb by of m vb square. So that is before, vb is before, va is after. Okay, if you consider what happened, m get cancelled, half get cancelled, VA is root GH minus, for that square is there, my root 2GH whole square by root 2GH whole square into 100. So mm cancelled, everything cancelled, half cancelled. So that's why I am writing directly VB square is there here. So GH, so what happened? 2GH minus GH is GH by 2GH. So this is modulus you can take. So into 100. So that means what is the answer? 50%. GH cancelled. You will get 50%. Okay, 50% and root 2GH is the answer. So I didn't do much. The only thing I applied kinetic energy conversion. Okay, that's it. Our total energy is that only. Here, whatever energy we are taking, total energy is of m into velocity square. Okay, total energy is that only. Well, it is converting from one form to another form. That's it. So another thing, here problem, if you observe, body of mass 50 kg is lifted to a height 20 meters from the ground in two different ways. One is in this way. Okay, if you consider this is ground to A. In this way he is moving. Another thing is pulled straight up. That is first case. Second case is along the ramp. So like this it's going. We know that work done depends on initial and final points, but not on the path. So it is not a path function. It is not going. Work is not dependent on the path we followed. Work is dependent on the initial and final points. So if you consider this is okay, something like this. So it may go like this or it may go like this. Work AC is equal to, this is 1, 2, 3. So in 3 different paths if it is going, work done is equal to work C minus work A. That means it does not depend on the path. It is dependent on the initial and final points. That means work C minus work A only. Here from the ground to top only. That means it is whether you go this way or this way, all paths same work. That's why it is 1:1. So here from the ground, whether you are going this way or this way, both are same. Okay. So for this problem, for that problem, you need only concept. So if you see the problem, that is a big thing. But if you have concept, you can clearly solve the problem. Okay, another one. Yeah. Now going to this one. Here what happened? Here 5 kg mass is coming down in this one. Here 2 meters it gone like this and it is hitting a spring. So here frictional force is there. Okay, that is equal to U delta U plus delta K. So energy is converting. Okay, here it's going like this. So here initially there is nothing, but here it is moving like this, mg. Okay, 0 minus mg into distance s, this one, plus half kx square. Here frictional force, how you are taking? It is coming like this. Okay, that is you can take mu mg cos 30, cos theta. Okay, frictional force is like this. So if you calculate it, k value is given 100, mu is given 0.5 into m is 5 into g value, how much? G value if you consider 10, cos 30 is root 3 by 2 is equal to mgh. Okay, mgh is this one position, it's coming like this. So mgh distance is this one. So 5 into 10 into 2 plus half k. K value is given 100 x square. Directly you will get. So frictional force is released like this. It's coming, that will transform into this one and it is hitting that. you can calculate the x value directly. Okay, so you just check it, maybe it is around 1 meter, so you just calculate it, take it as homework. Okay, here what happened, block is coming like this and going like this and hitting the spring, so we need to calculate the x value, that is compression the spring when the block hits that one. So this force is coming and hitting this, that's why I am taking, so whatever amount of force, that is frictional force, changing into total energy, that is Ke plus Pe. So here it's changing like this and we can hit that. Okay, you just take care of that one. Another one, here also a particle of mass m moves along a straight line with its velocity increasing distance according to the equation where alpha is the constant. Work done by all the force applied on the particle during its displacement from one place to another place. If you observe here, work done is equal to, what is this? Particle is moving with velocity, that is v is equal to alpha root x. Yet x equal to 0, if you keep x equal to 0, v is equal to 0. X equal to d, x equal to d, he told. V is equal to, what is it? Alpha root d, that is alpha into root x, alpha into root x. So what happened, you know, work from work energy theorem, work done equal to change in kinetic energy, work done equal to change in kinetic energy, work done equal to change in kinetic energy, that is half m v2 square minus half m v1 square, that is half m into alpha root d square minus half m 0 square, 0 square. So here half m alpha square d minus 0. So m alpha square d by 2, that is a work done. Simple. So not even one line. So if you understand that, you can get the answer. Here force is given, that is 60 I cap plus 60 square j cap. Power developed, we have to calculate power. So here another thing is mass is also given. So if you observe here, work done equal to force into displacement, that you know, F dot S, whereas the power is equal to force into velocity. Again, this is also dot product, F dot V bar. Okay, F dot V bar. But here what happened, F bar is given, but we don't know V bar. How to calculate? So F is equal to MA is equal to 60 I cap plus 60 square j cap. So acceleration is equal to 60 I cap plus 60 square j cap by m. What is the value of m? 2 kg. M is 2. So then 3t I cap plus 3t square j cap, that is acceleration. Whereas acceleration is also vector. But what we want? Velocity. We know that acceleration is equal to dv by dt is equal to 3t I cap plus 3t square j cap. dv is equal to 3t I cap plus 3t square j cap dt. Integration, if you apply, what happened? 3t square by 2 plus 3t cube by 3 from the limits 0 to t, 0 to v. So if time is 0, velocity 0, time at time t, velocity is v. So that is v minus 0, v you will get. So 3t square by 2 plus t cube. I cap is there, here j cap is there. This is the velocity, v bar. What we want? Force into displacement, that is P is equal to 60 I cap plus 60 square j cap dot 3t square by 2 I cap plus t cube j cap. J cap is there. Okay, j cap. So I dot I, 6 3 is 18 by 2, that is 9 t into t square, that is t cube I cap. 6 t power of 5 j cap. This is the answer. 9t cube plus 60 power of 5. It's not j cap, I cap won't be there because I dot I 1, J dot J 1. This is in which units? Watts. Okay. Okay, this is the answer. Yeah. Now going to the next one. So here another problem is also related to power. Here what is given? Constant power source. Power is constant. So if you consider power is equal to constant, what you know? Power equal to force into velocity, F dot V. Force is equal to MA into V is equal to constant. M into dV by dt into velocity is equal to constant. Okay, that means V dV is equal to C dt by M. So C by M is again constant, mass is constant, fixed. Unidirectionally it is going. If you apply integration V dV from 0 to V limits is equal to 0 to T dt. So what happened? V square by 2 is equal to T. V is again 2T, it will be there. V square is proportional to time T. But what we want? Displacement. Okay, displacement. V is proportional to T power 1 by 2. So velocity is equal to displacement by time, that is ds by dt equal to T power 1 by 2. Constant again. That's why ds is equal to T power 1 by 2 dt. If you apply integration again from 0 to S, 0 to T, that means at 0 time, that means T equal to 0, S equal to 0, T equal to T, S equal to S. So S minus 0, that is S, T power 1 by 2 plus 1, that is how much? T power 3 by 2. Okay, S by 3 by 2. Again 3 by 2 is constant. S is proportional to what? T power 3 by 2. Okay. So if you observe here, so displacement is proportional to T power 3 by 2. Okay. Now going to the potential energy and equilibrium. Here potential energy is given, potential energy function is given, that is U is equal to this one. Here x, y, z are in meters. Magnitude of x component of force. So what we want? Fx we want. At which point? 1, 2, 3. Here if you see potential energy function is given, that is U is equal to 2x square plus 3y cube plus 2z. But what we want? Fx is equal to minus du by dx. Here we don't want other things, only Fx we want. You can take that one, that is 2x square by d by dx of 2x square. So 2 into 2x, that is at x value 1, at x equal to 1. Okay, so that is the thing, that is 4 into 1, 4. This is the answer. Directly you will get, because he is asking only Fx. Fx is equal to minus du by dx, so it will be in opposite sign, but the value will be 4 only. Okay, now going to the next one. So that are the things related to work, power, energy. So we solved all the problems related to that. So thank you once again. All the best.